So what this is saying is that because this is that to that is 1 to 7, then what that means is it means that x plus 1 is equal to 3. In fact, we could say it's 7 times x plus 1 is equal to 3y. Okay, it's a bit confusing there. Why did I seem to have swapped the 7 and the 7 and the 1 around? Well, the reason is because the bit on the left is one. What the ratio is saying is that the bit on the left is much smaller than the bit on the right by 7 times. Okay, so x plus 1 is equal. X plus 1 multiplied by 7 would be equal to that. So you could then divide it out and say x plus 1 is equal to 3/7 of y. And well, likewise, do you want to see if you can work out what the equation would be for this one here on the right? So we've got equation 1, x plus 1 is equal to 3/7 of y, and then, or basically 1/7 of 3y. But anyway, then we've got 2x. So this is equation 2. 2x is equal to 2/5 of y plus 3, because it's the ratio is 2 to 5, so it's saying that is smaller than that one by a ratio of 2 to 5. So it's, in other words, it's 2/5 of the bit on the right. So let's just move this to the side, and we'll just put these two equations in sort of list format, in a list form. Okay. Now what we do is we're going to try to rearrange these formula to so as we can essentially combine them and have one of either the x or the y cancel out, and this would mean that we can actually have an equation with one variable. So the problem is, whenever you solve any equation, you can't solve an equation if it's got two unknowns. I'm just going to move yours up there for a moment. We can't solve an equation with two unknowns because we don't know, so for example, if a plus b is equal to 4, well, a could be 2, b could be 2, or a could be 1 and b could be 3. There's an infinite different possibilities, and so you can't solve an equation with two unknowns. You can solve two equations with the same two unknowns because you can combine them. There are some exceptions when that still can't be done, but I won't go into that at this point. So I would, to be honest with you, use the sort of fail-safe method of solving simultaneous equations. A lot of teachers will teach you some shortcuts, which will be really good. We can go into that later on. But what I would do is I would basically rearrange it to say x equals. So do you want to rearrange the top equation so as it says, in fact, do you want to just tell me what would I have to do to rearrange the top equation so that it says x equals? That's right, yeah. So whatever you do to the left, you must do to the right. So we've got x is equal to 3/7 y. Whoops, that was not a y. Minus 1. Now, if that's what x is equal to, then in equation 2, instead of writing x, I can just write that. So in other words, instead of writing 2x, I write 2 times 3/7 y minus 1. And then I write the right-hand side of the equation, 2/5 y plus 3. Now we have an equation with only one unknown, and so in theory, we can solve it. So do you want to see if you can solve that? I would say the first thing to notice about this equation is that both sides can be divided by 2. we've got 2 times this is equal to 2 times that. So let's just start off by dividing it by 2. So I'm just going to delete that 2, write a 1, and delete that 2 in that bracket. So now we've got it's a little bit simpler already. So again, whatever I do to one side, I must do to the other side. I think the next thing we're going to do to neaten it up a little bit is we want to try to get rid of these brackets, really. So let's multiply the whole both of them by 5. So if I multiply the right-hand side by 5, it cancels out the 1/5, and the right-hand side is looking a bit neater. And then we would have to multiply the left-hand side by 5 as well. Okay. Now, actually, I need to make sure I put all that in a bracket because I've multiplied the whole of the equation on the left by by 5. Then I would expand out that bracket, and so I've got 15 over 7 y minus 5 is equal to y plus 3. So that's looking good, no brackets, and we can start to collect the terms. Okay? So if I add 5 to both sides, what happens is the 5 goes over to here, and we have add 5 there. We then get rid of that minus thing there, so we end up with this. Rearranging equations on mirror is quite cool because you can just keep using the same equation as long as and then if you're recording it, then you know what the steps are. I might add some of the steps. In fact, what I'll do now is I'll just shrink this so we have a bit more space to play with. Next thing I would do is take away y from both sides. So this becomes 15 over 7y minus y. And that's equal to, and let's combine 2 steps. Let's add the 3 and the 5, and that gives me 8. Okay. So what I would do now is I would expand out, because basically we want to try to collect these terms. Okay. Well, actually, we could just collect them straight away. We don't have to expand out the brackets. I think let's say that, well, basically it's 15 over 7 plus 1. So 15 over 7 plus 7 over 7, because 1 is 7 over 7, if we want to keep them the same. So 7 over 7 plus 15 over 7, that'll be 22 over 7. So it'd be 22 over 7 times y is equal to 8. And now we would multiply by both sides by 7. So we'd get the 7 go up there. And then we would divide both sides by 22. So 22 would go there. And we've got what we need to put into our calculator. And once you've got that, you can then rearrange it. And earlier on, we had x is equal to 3/7 of y minus 1. So you could just put that into that equation once you've got a value for y, and you'd be able to get a value for x.